Hello. Yeah, hi, good evening, all of you. Thank you all for joining the session. Let's wait for 1 to 2 minutes so that other people can join. Okay, let's start the session first. So today we are going to cover some of the topics of Palo Alto and GFW. Okay, and GFW stands for Next Generation Firewall. Okay, we'll cover in today's session. We'll cover what is firewall and types of firewall. Secondly, why to choose Palo Alto firewall over different firewalls available in the market. Third topic will be initial configuration of Palo Alto firewall. Such as interface configuration, zones, VR, and management profile. The fourth topic will be basic NAT and security profile. For internet action. The fifth topic will be site-to-site Ipsec Vpn. And the last one, HA basic setup. Okay. All right. So what is firewall and types of firewall? The first topic, right? Let's design a basic topology here. So here is the Palo Alto firewall. Our core switch. And this is our internet. Okay. So firewall is similar to our layer 3 device, such as router. Okay. But with advanced feature set to protect your local network, right? Basically, it is meant to protect your organization's private network from public network, because online attacks happens mostly from the internet or from the public network. So internet is our public network. Most of the attacks happens from the outside to our internal network. So Palo Alto firewall is there to protect our local network, our private network from the internet. Like the threat vectors are there on the internet, right? Firewall sits between the public and the private network, which will be segregating both the public and the private network. It is segregating. Here are our public network, it's our private network. It's segregating both the public and private network and restricting public network to access our private network by configuring some policies as per our requirement. All right. Am I clear? So move to the next topic, types of firewall. Basically, there are like 3 to 4 types of firewall available in the market. The first one is the packet filtering firewall. The second one is the application gateway. The third one is the stateful packet filtering firewall. And the fourth one is the application aware firewall. So what's the difference between all these segments? If you talk about the packet filtering firewall, what is the use of packet filtering firewall, such as your Cisco routers ACL? Like you have a router here placed in your organization, it is connected with the internet, right? And here is your LAN network, right? So what packet filtering firewall do here? A packet filtering firewall examines each packet that crosses the firewall. For example, if you are accessing the Facebook, it is crossing the Palo Alto firewall or the packet filtering firewall. The packet that crosses the firewall and tests the packets according to some set of rules that we have configured based on that allow or deny the packet to pass through the firewall. On the packet filtering firewall, we just filter the packet based on our basic configurations such as ACLs. We can filter the traffic based on source and destination IPs and port numbers only, not more than that. So this is called the packet filtering firewall, such as your router. On router side, when you configure any ACL to to deny some traffic, that is similar to packet filtering. So in early days, the packet filtering firewalls does the same thing. Okay. Now the second thing is application gateways. What application gateways does here? It is such as proxies. If you are using proxies in your network to access internet, it is similar to application gateways. So we use the proxies to bypass the security policies to get the internet access. For example, if you are having any like firewall placed in your network as your internet gateway and it is connected with the internet, when any users want to access the internet, it will move through the firewall. But if you have like placed any proxy server here, so your traffic will move to that proxy server, and through that you can directly access the internet. It will pass all the security profiles policies you have configured on the firewall. To bypass all the policies, all the security profile, we use the proxy servers. So application gateway performs the same thing. The third one is the stateful packet filtering firewall. It is the latest version of packet filtering and the application gateway. So in that segment, what firewall does here? Basically, stateful packet, it perform the stateful packet inspection. Again, take an example here. You are having any firewall here. Once the user wants to access the internet, it went through that firewall and moved to the internet, right? If you are accessing Facebook, Gmail, it moves through the firewall because firewall is placed in between of your public network and the private network, right? So here, this stateful packet filtering firewall inspect, like stateful packet inspection is happening here. It is the technology through which firewall monitors the state of the connection and complies the information in a state table. It monitors both the incoming and outgoing traffic, and based on the configured policy, allow that incoming and outgoing traffic through the firewall. Here, if user accessing any web applications like Facebook, then what firewall does here? It plays the information like source IP and destination IP, source port, destination port, even the protocol. It plays all these information in a state table on the Palo Alto firewall when the traffic is moving from the user to the internet, and when the vice versa traffic is coming from the internet. When the traffic is coming from the internet to the user, this firewall checks the state table, and in that it checks the source IP, the destination IP, source port, destination port. If that complete set is matched, it can confirm the user is accessing that application. It means it's a legitimate request coming from the outside to the internal user. Then it allows that traffic. If that information which is there on the state table of the firewall doesn't match, it doesn't allow that traffic to come inside to the internal network. So stateful packet filtering firewall inspect all the traffic sessions and allow that, like it monitors both the incoming and outgoing traffic, and based on the configured policy allow the incoming or outgoing traffic through the firewall. Okay, now the advanced version, the application aware firewall. What is application aware firewall? The firewall which is having the capability to detect the application traffic passing through the firewall. It opens the packet up to layer 7, and based on that allow or deny the traffic is called the application aware firewall. Whereas the traditional firewall can, like the stateful firewall, the application gateway, and the packet filtering firewall, these firewalls can only block the traffic based on ports and the addresses. So this is the advanced feature set which is available in the latest firewall segments, basically in the Palo Alto firewall or in the Cisco firewalls. Okay, am I clear? Okay. So why to choose Palo Alto firewall over different firewalls available here in the market? Basically, Palo Alto was the first firewall which called as the NGFW, next generation firewall. Why? Because it comes with the advanced feature set such as app ID, content ID, URL filtering, app ID, content ID, URL filtering. It comes with this advanced feature set in the market to protect your local network from the outside. Okay, you are filtering all these things in a single hardware box. Before that, we use UTM. So UTM is Unified Threat Management. Here we can like integrate multiple technologies, multiple firewall segments, like for URL filtering, different box, for threat prevention, different box. But in Palo Alto firewall, all these things, all these feature sets are available in a single hardware box, right? Palo Alto is the leader in the network firewall segment as per the Gartner Magic Quadrant. I'll show you. You can see here, this is the Gartner Magic Quadrant. Is the open organization and that performs the survey for all the networking devices, even routing, routers, switches, firewalls, all the segments. So as per that, Palo Alto is the leader in the network firewall segments. Fortinet is also there, Checkpoint is also there, but if you're talking about the leader, Palo Alto is the leader in the network security segment. Okay, it like if you worked on routers, for example, Cisco routers, they run on the iOS, right? Internet operating systems. They have their own iOS XCSD and something. Okay, so similar to that, Palo Alto firewall works on its own operating systems, which is called as PAN-OS. Palo Alto Network OS, operating system. Okay. Let me know if you have any doubts till this point. Just comment. Amit is asking packet filtering but versus stateful packet filtering. On the packet filtering firewall, we can filter the traffic based on the packets, right? If you are familiar with the OSI model, so your packet moves on the layer 4 transport layer, right? So in the packet filtering segment, in the packet filtering firewall, we can filter the traffic based on the packets. Here we can match the source IP, the destination IP, the source port, and the destination port, right? Apart from that, we cannot like match anything. We cannot like investigate the packets, other packets, the like traffic of the application. But if you are talking about the stateful packet filtering, here, if this firewall is a stateful firewall, if this firewall is the stateful firewall, it means it creates the sessions, state table, all the sessions information in the state table. In the packet filtering, we can filter the traffic based on the packets only. There is no state table available on the hardware. But in the stateful packet filtering firewall, the firewall having the information of all the sessions in their state table. And based on that, we can filter the traffic. We can apply some policies to allow or deny the traffic. If your user is moving from the firewall to access some services on the internet, all the information, source IP, destination IP, source port, destination port, and the protocol, all this set of information placed in a state table. And once your request reach to the server, and that to fulfill that complete 3 handshake and the data processing, that request came back with the data to the user, right? Then firewall checks the state table, all the information like source IP and the destination IP, source port and the destination port, all the things will be matched with the state table. If that information match, then after the firewall allows your traffic to come inside of your local network. Otherwise, on the same side, it denies the request. Okay. So let's design a small topology here. It's a basic topology for your network. Like it's a core switch placed in your organization, which is connected with the Palo Alto firewall. And the Palo Alto firewall is connected with the internet. Let's give the nomenclature to that. For example, it's a server placed in your organization. For example, it's a banking server. Okay. So here on the Palo Alto side, Palo Alto is a zone-based firewall, right? What is zone actually? So it means we have to create zones such as LAN, as trust. It's our LAN network. It's our WAN network, right? So we have to create the zones here. LAN. We can give it the names like trust zone because we trust the LAN network. It's a WAN network. So obviously it's untrusted. It is the management PC through which we manage the Palo Alto firewall. So what happens? Like, for example, if any user, Palo Alto is placed here as the network gateway, right? So the main function of the Palo Alto firewall is to protect your local network. But for configuration, because it's a zone-based firewall, so we have to create a zone. We have to map the interfaces, LAN interface and WAN interface to a particular zone. It's a zone-based firewall. So we can give it a name as trust, inside, whatever the name you want to suggest it. We can give that name to its interfaces. Okay. So normally we use the LAN as trust zone, WAN as untrust zone, and DMZ server, DMZ zone as a server zone. Okay. It doesn't work on security level because this Palo Alto firewall, it doesn't work on the security level, such as Cisco. In Cisco ASAs, where traffic from higher security level to a lower security level allowed by default. If you're talking about the Cisco ASA, so in Cisco ASA, basically, what happens? If you assign the LAN interface as the inside and the WAN interface as the outside, LAN as a inside, so by default, it assigns the security level of 100. WAN or outside, and by default assign the security level of 0 in Cisco ASA. So what happened in Cisco ASA, from the higher security level to the lower security level, traffic is allowed by default. The internal network can access the external services by default, right? There is no policy required for this. You just give a name to that interface. By default, it is mapped with the security level. For inside, security level 100. For outside, security level 0. And that's why from the internal network to the external network, the service is allowed by default. But here in the Palo Alto network, if we are talking about the Palo Alto device, it works on the security zone, right? We have to assign the interface in the security zones, such as LAN for trust, WAN for untrust. It doesn't assign the security level for the interfaces. It doesn't assign any security level for the interfaces. We just assign that interface to a particular zone. We just give it a name like trust zone, untrust zone, and DMZ for server zones. So if there is no security level, so what we can do? So for that, for internet access or the public network access, we need to create the policies. For everything, we need to create a policy. To access from the internal network to the internet or to the public network, we have to create a policy from trust zone to untrust zone. So security policies should be configured to communicate between different zones. Here in our example, we have two different zones. For LAN, the name is trust zone. For WAN, the name is untrust zone, right? So for communication between trust zone to untrust zone, we have to create a policy, a security policy. Otherwise, there will be no communication. Okay. Am I clear? This is fine. So for communication between two different zones, we have to create a policy, security policy here. Otherwise, there will be no communication. If you want to communicate between trusts to untrust, we have to create a policy. For if you want to communicate vice versa, like from untrust to trust, we have to create a separate policy for that. If there is any server is connected here, for example, this is your server and it is placed in the DMZ zone, and you want to allow access from the public internet network to the DMZ, then we have to create a separate policy for that. So for each segment of communication, for different zones communication, we have to create a policy. Based on that, we can allow or deny that traffic. Okay. So for initial configuration of the Palo Alto firewall, we require the Palo Alto firewall GUI access. And the default username and password for the Palo Alto is admin. To access the Palo Alto firewall, the default username password is admin. So for that, to access the Palo Alto firewall for the initial configuration, we need to connect the management PC with the Palo Alto firewall on the management interface. And the default IP of the Palo Alto firewall is 192.168.1.1/24 with the subnet mask of /24. So what we have to do is we need to assign the same subnet IP to our system, to our machine, to access this Palo Alto firewall. Let's jump to the lab first, then we'll discuss further. So this is our topology for this session. First, the initial configuration of the Palo Alto firewall. Okay. In this basic topology, our LAN network is this 10.0.0.0/24. .10 IP is here. .1 IP is on the Palo Alto side. The WAN interface will be on DSCP, and you can see here it's our management interface through which we'll get the access of the Palo Alto firewall. We'll perform the basic setup from this interface. We'll use a machine to connect the Palo Alto firewall. Let's start all the nodes here. We'll configure here in this topology, we'll configure the interfaces such as layer 2 interfaces, the virtual router, the management profile. Okay. Let's wait to start this window machine first. Then we'll start the basic configuration, the initial configuration of the Palo Alto firewall. It's our third topic. Initial configuration of the Palo Alto firewall. Will perform interface configuration zones, VR, virtual router, and the management profile. Okay. Let's check the IP address first. Yeah, it is in the same subnet, 192.168.1.10. Let's try to ping the Palo Alto firewall from our machine, 192.168.1.1. It is the IP address of the Palo Alto firewall, management IP address. It is default. We can change it, but it is default. Okay, let's try to ping. Yeah, it's pinging. Let's try to get the access. On this management interface, by default, ping, SSH, and HTTPS is allowed by default on the management interface, so that user can connect its management PC with the Palo Alto firewall to get the access and to configure the Palo Alto firewall. But apart from this, on the data interfaces, such as this LAN interface and this WAN interface, apart from the management interface, all the interfaces are like, we have to enable the services. By default, there is no service allowed on the data interface, like ping, SSH, HTTPS. Nothing is allowed by default on the data interfaces. So for that, we have to create a management profile. But by default, on the management interface, these services are allowed: ping, SSH, and HTTPS. Okay. It is like we are accessing this Palo Alto firewall for the first time. Okay. So nothing is configured here. It is the first time we are accessing this Palo Alto firewall, such as from the scratch, we are building the topology. So this is the default IP 192.168.1.1, for which we can configure this Palo Alto firewall, and the username and password default is admin. Okay, clear? Once you click on the OK button, after giving the username and password, it will give you the first page where you can see multiple things on the dashboard side. It is the first page of the Palo Alto firewall. What you can see here, the device name, such as the host name, it is Palo Alto VM. The management IP, which is by default 192.168.1.1 with the /24 mask. Okay. You can see the model, it's a Palo Alto VM. Serial number is showing unknown because this box is not licensed. Once we license this box, there will be some value, the serial number. This is CPU ID and UUID, which is used for the licensing of the Palo Alto firewall. Okay, apart from this, you can see here in the logged in admins, it is showing the person who is logged in the Palo Alto firewall as of now. Only single admin is there. It's my PC with the IP address 192.168.1.10. The access is web based. It means the GUI access is there. Okay, the session is start timing, the idle for this. So these are some basic details which is there on the dashboard side. Apart from this, if you want to like remove or add some other parameters, you can easily do that. Such as if you want to remove the data logs from this dashboard, just click on the cross button, it will move. And if you want to add another like top application, yeah. And for example, if you want to add threat logs information on the dashboard side, then you can easily attach from the widgets. It's very simple. You can easily move these widgets as per your requirements. If you want to move threat logs on the bottom side, you can do that. This is the dashboard of the Palo Alto firewall. Okay. So let's move to the configuration part. Here in our topology, what we have to do is we have to configure the LAN part, the WAN part to access the internet. So what we have to do is we have to configure this internet interface, LAN interface, the WAN interface, and in between we have to create a NAT policy and the security profile to access the internet. So for that, what we have to do is click on the network tab on the interface. On the Ethernet 1/1, we have to assign 10.0.0.1/24 mask. Ethernet 1/1. Click on this. Once you click on this, it will give you some information like the configuration tabs here. We are on the interface. It is showing that we are on this interface Ethernet 1/1. Interface type is as of now tap mode. We'll discuss it in further videos. So what we have to do is just click this drop down button. Here you can see 5 interface types. By default, it's on tap. There is a HA, virtual wire interface is also there, layer 2 interface and layer 3 interface. For the communication between like 2 different zones, firstly, we have to create a layer 3 interface and then assign the IP address on that interface. And then we have to create security profile to communicate between different zones, right? Click on layer 3. Once you click on layer 3, you will see we have 2 different options to configure the virtual router and the security zones. Okay. So what is virtual routers? If you are familiar with the VRF, so virtual router is similar to VRF, having its own separate RIB and FIB, routing information base and forwarding information base. If you configure like if you are having 3 different interfaces on Palo Alto firewalls and you configured all three interfaces in a different VR, it means they are having their own separate RIB and FIB. And as of now, we are not configuring different RIBs, FIBs. We are using the default virtual router. Okay. So what is there in the like VRF? All the like routing information. If we assign similar, like we have 3 interfaces, we assign a single VRF or single virtual router to all the interfaces. It means all the RIB and FIB is single for all the interfaces. There is no separate routing information base or forwarding information base. It means all the 3 interfaces are connected with each other. Click on the default. Now, what is security zone? As I already told you, we have to assign the interface to a particular zone. We can give it a name, whatever the name it is, like LAN, WAN, inside, outside, and if there is another name is there, we can configure that name. So for how to configure that, just click on the drop down button. click on the zone. As I already configured the LAN zone here, just click on, give it a name as LAN or inside. Click on the OK button. You can see this interface is assigned to inside zone. Okay. Now you have to assign the IP address, IP version 4 address. So what is the IP? 10.0.0.1. 10.0.0.1/24. So what we have configured till now, we have changed the tap mode to the layer 3 interface type as a layer 3 interface. On the config part, we assigned the virtual router as a default router, security zone as inside. We configured the inside interface for this Ethernet 1/1. We assign the IP address to that interface. Okay. Now click on the advanced tab. Like I told you, on the management interface, all these services are allowed by default. But on the data interfaces, ping, SSH, HTTPS, nothing is allowed. So for that, we have to create a management profile and attach that profile with the interface. How to do that? Just click on the advanced tab. Here you can see the management profile. Right. Just click on the drop down button. Click on the management profile. Here you can see multiple services are there. As per your requirement, you can enable the service on that interface, like ping, SSH, HTTPS, SNMP, even HTTP or telnet. Okay, as per your requirement, you can enable the service, but we just enable the limited service for testing, such as ping, SSH, and HTTPS. Just click on the OK button. So that profile, management profile, is attached with the interface Ethernet 1/1. In that management profile, we allowed ping, SSH, and HTTPS. Okay. Just click on the OK button. You can see Ethernet 1/1 interface type is changed from tab to layer 3. The management profile is attached, which we configured earlier on the advanced tab. The IP address, which we assigned to that interface. Apart from this, the security zone is there inside. Same thing we have to do for the WAN interface as well. So our WAN interface is 1/Ethernet 1/2. So for this Ethernet 1/1, the LAN interface, we have assigned the static IP 10.0.0.1. But for the WAN interface, we don't have the a static IP because it's connected with my system's NIC card. So for that, for IP address assignment, we have to map this interface with the DSCP. We have to configure the DSCP interface here. It will be layer 3 interface, but the IP address assignment will be DSCP, not static. Configuration is very simple. Again, click on the Ethernet 1/2. Change the interface type from tab to layer 3. Again, the virtual router, the VRF. So we are using the default virtual router. Security zone. Give it a name as outside. Click on the OK button. Again, the IP address assignment, you can see here, we have 3 different types: static, triple PoE, and DSCP client. So this interface will be the DSCP client because it is connected with the local machine's NIC card. it will get the IP address from my local wireless network. Okay. Now again, come to the advanced tab and attach that profile which is configured earlier, the management profile, where we allowed some services such as ping, SSH, and HTTPS. Just click on the OK button. All the configuration is similar, like both the interfaces are layer 3, the management profiles are there in both the interfaces, but on the IP address side, you can see for Ethernet 1/1, the IP address is static, but for Ethernet 1/2, we have configured the DHCP client. And the zone, you can see here, zones are different. Inside for 1/1, outside for 1/2. Okay. Now the interface configuration is done. We have configured the layer 3 interface. We have configured the VR default security zones. We have configured and given the IP version 4 address for the interface, and the management profile is also there. Okay. At this point, we have configured the interfaces. Click on this commit button. And if you can see here, it will ask you to commit, close, validate changes, or preview changes. Once you click on the preview changes, click on the OK button. Block the pop-up. Again, click on the preview changes. Click on the OK button. It will show you in the colored segment, green in the added, yellow in the modified, and red in the deleted. Okay. Scroll down. You can see like these are the modified changes. This is my running configuration as of now, and this is candidate config. So here you can see we have configured the inside interface given layer 3, outside interface as layer 3. Click on the commit button. It will take some time, then commit will. Till this point, we have configured some very basic configurations such as internet interface configuration as layer 3, the VR configuration, virtual router configuration, the management profile assignment to the interfaces, and the security zone configuration. Nothing else. We don't have the internet access till now because we have not configured any net profile, any security profile for the LAN network. Let's try to get the access of the Alto firewall from SSH. As I told you, we have like the services allowed on the management interface, SSH, HTTPS, and ping. Okay, click on this 192.168.1.1. Open this. The username and password is admin in small. Once you put this command show interfaces all, it will show you all the interface configuration. We have two interfaces, 1/1 and 1/2 connected here, and the IP assignment, the static IP assignment, and the DHCP IP assignment on the outside interface. Once you if you want to like check the connectivity, because in our network, in our setup, our Palo Alto firewall is connected with the internet, right? We have not configured the policies for the internal network, but here on the WAN network, we have the IP address from the DHCP server. So we can check the connectivity from this Palo Alto firewall to the internet. We can check that. Okay. For that, just ping source. What is the IP address on the WAN interface? 192.168.31.131, and the host 8.8.8. Yeah, it's reachable. It means on this interface, it means on this interface, on the WAN interface 1/2, this IP is routable to the internet. We have the internet on the Palo Alto firewall, but we have the internet from this interface to the internet. But for the LAN network, we have to configure a policy. We have to configure the NAT as well. Let's configure the same thing as well. So here on the network tab, what we have configured, the interface 1/1 and 1/2 for the LAN and for the WAN. Right. Let's create the policy. Firstly, we'll configure the NAT part. Okay. Here we will configure basic NAT and security profile for internet access. Go to the policy, click on the NAT button. Once you click on the NAT tab, here you can see on the bottom side to add. It's very simple. Click on this add button. Give it a name such as internet access. The name could be anything. It's just the nomenclature. Okay. So whatever you want to assign the name, you can assign. So we are assigning it as internet access. Click on the original packet. Now there are like multiple things are showing. First one is the source zone, the destination zone, destination interface. Right. So we are doing the patching. We are not like configuring NAT, static NAT or dynamic NAT. We are using patching here, port address translation. Okay. If you have done the CCNA part, then I think you should be familiar with all these NAT, PAT, and static NAT concept, right? Dynamic NAT, static NAT, and the PAT. So we are configuring the PAT here. Here on the source zone, what will be our source zone? The inside network. Click on this add button. You can see inside, outside. So source zone is our inside. Now the destination zone. What will be our destination zone? Obviously, the WAN zone, the outside zone. Drop down this. You can see here outside. Now the third part, destination interface. So it is our destination interface, Ethernet 1/2. Click on the drop-down button. Here you can find Ethernet 1/2 is there. Services, we are not changing services because by default it is showing any. It means all the services are allowed by default here. But I'll show you the services. It will show you the HTTP and HTTPS services. So by default, we are allowing all the services. We are not like pointing any service here. Click on the third tab, translated packet. Click on the drop-down button. Here you can see dynamic IP and port number, dynamic IP and the static IP, static NAT, dynamic NAT, and the PAT. So we are doing dynamic IP and port. Second tab, once you click, like if you select the none, there is nothing, no configuration is showing. Once you click on the dynamic IP and pad, it will ask you the address type. Click on the drop down. It will show you translated address and the interface address. You have to configure the interface address. You have to take the interface address when the LAN user is accessing any application on the internet, then it should take the interface address. Third tab, the interface. What interfaces are, we have to select the WAN interface. It is Ethernet 1/2. You can see here, like on the IP address side, it is showing none. If I select 1/1, it will show me the IP address. Why? Because on the LAN side, we are using the static IP. So static IP is permanent IP, right? On the WAN side, we are using DSCP. So DSCP address will change once my router reboots and or like that lease time expires. This IP, this DSCP IP will change. So if I select this as the interface Ethernet 1/2, because it's my WAN interface, there is no IP showing. So what it means, it will take that IP which is available on the interface Ethernet 1/2. When the traffic is passing through the firewall, at that time, whatever the IP is available on the Ethernet 1/2, it will take that IP to access the internet. Just click on the OK button. So here, this profile is configured, net profile. You can see from the source inside to the destination outside. The destination interface Ethernet 1/2, source address any, destination address any, service is any by default we are using. Source translation dynamic IP and port on Ethernet 1/2. Okay, very simple. Now the last thing, we have to configure the policy security profile to access the LAN network, to access the internet through this Palo Alto firewall. Once you click on the security profile, you can see there are two policies by default configured on the security tab. So you can see like here intrazone default and interzone default is configured. So what is intrazone and interzone? I think you all are familiar with. So intrazone is within the same zone, intrazone traffic. Like on the core switch, if you are having default like VLAN 1, all the interfaces are in the VLAN 1, right? If this PC is having 10 IP, this PC is having 20 IP, by default it is allowed because it's intrazone communication, right? But if, for example, if there is another VLAN, another switch available with the VLAN 20, and you want to communicate between two different VLANs from VLAN 1 to VLAN 20, then the traffic will be interzone between two different zones, between two different VLAN, right? It's our intrazone, interzone. I'll show you the difference here. On the action tab, you can see on the action tab, intrazone traffic is allowed, but interzone traffic is denied. It means if the traffic is within the same zone, traffic is allowed without any security policy configuration. But if the communication is happening between two different zones, it means we have to create the policy. Or if there is no policy configured, that traffic will fall in this policy, the interzone policy, and the action is denied. So that traffic cannot move from one zone to another zone. So for that, we have to create a separate policy. We cannot change this default policy. We have to create a separate policy. Click on the add button. Just give it a name as internet access policy. Click on the source. We are taking source as the inside zone. Traffic is coming from the inside. We are not configuring the users as of now. It's a separate concept. Destination. What will be the destination? Outside. Okay. User is coming from the inside and moving towards the outside. Application, any. We are allowing all the application as of now. We are not filtering any application. We are allowing all the services. We are not blocking any services as of now. The last step, what we have to configure from the very beginning, we have to assign a name to the policy. We have to give the, we have to assign the source zone from where traffic is coming, destination zone where traffic is moving, and the last one is the action tag. Very important. Here you can see, if you click on the drop down button, there are multiple options: deny, allow, drop, reset client, reset server, reset both client and server. So as of now, we are just allowing all the traffic from the LAN network to the WAN network. Palo Alto is not denying any user, any service. We're just trying to allow all the traffic to pass through it based on the policy. Click on the allow and click on the OK button. Let's check that internet is working there or not. Try to access YouTube. As of now, internet is not running on this window machine, the virtual window machine. It's my management piece system, and the other one is the LAN system, LAN machine. Okay. Click on the commit button. This is all done for the basic initial configuration. We have configured the interface with the layer 3. The IP address assignment is done. The zone is configured for both the interfaces. The management profile is attached with both the interfaces. Now on the second side, we have configured a net profile for the patch and the security profile to internet for the internet access between two different zones. Once that policy is saved, you can see here. Let's minimize this step. You can see here, YouTube is the page of YouTube is there. It's opening here on the virtual machine. It means our LAN side user can access the internet now. It means our policies, our configurations are working here. There's no issue in that. We can access the YouTube, Facebook. Let's hope it's working. Yeah, it's working. So we can use internet here on the virtual machine. So how to confirm that the internet is working? Click on this monitor tab. It's our management PC. Okay. This monitor tab, you can see session browser. It's the real-time traffic which is passing through the firewall. Once you click on this plus button, you can see two different flows are there. Flow 1 from the source zone inside, the source IP is 10.0010. The destination IP is there. destination port, right? It is from source to destination. Flow 1 is from source to destination, right? The stateful packet filtering firewall, I told you, it stores the information of the session in the state table. It is the actually information which is there in the state table. The flow 1 where the source zone, the source IP, the destination IP, the destination port, then the flow 2. The flow 2 is the flow from the server to the user again, the back vice versa traffic. Now here you can see from source is outside. The source IP is different. The like server IP, the Facebook's server IP, I think. The destination IP, the port, the destination IP is 31.131. It's not my Palo Alto machine's IP. It's basically my system, my laptop's the like NIC card's IP. Okay. The port number, from port, all the information is there. So it is actually the information which is there in the state table. Based on that, firewall allow the traffic, vice versa traffic, the traffic coming from the outside to the internal network for the user. Based on this information, firewall allowed the traffic. Yeah. Am I clear till this point? Let me know if you have any doubt till this point. Your Fishek is asking like for static net, dynamic net, and U-turn net. Okay. Static net, dynamic net, and the FAT. U-turn net is a like a different topic. We cannot cover this in this like session, but yeah, we'll cover this 3 net part. The static net. The static net is 1-to-1 netting, 1:1. Like the if you are having a single public IP available on your firewall side. Let's take an example here. Suppose it's your firewall or your router that is connected with the internet with a single public IP. For example, 200.0.0.1. Now your user are connected with the switch. Okay. And they do have IP of 10.0.0.1, and the second one is 10.0.0.2. So what a static net is, if you are having a single public IP available on your WAN side and you have configured the static net, it means you just map a single IP with the public IP, 1-to-1 netting. It means if someone from the outside try to access this public IP and 200.0.0.1, it will redirect you to this 10.0.0.1, not this on 2. Because we have mapped this 10.0.0.1 with this 200.0.0.1. That is called static net, 1-to-1 netting. Static public IP with a private IP, with a single private IP. That is called static net. Now come to the dynamic net. What is dynamic net? For example, if you are having a pool of public IP, such as 200.0.0.1 slash we can take, for example, 24, for example. It's a very big pool for a public IP. But yeah, for example, we have the pool of 255 public IPs available here. And in our LAN side, we have more than 255 users. For example, we have 500 users in our LAN. Okay. We have configured the dynamic net. What it will like done here, then in dynamic net, it like works on first come first serve basis. If the user one comes to the router will assign the first public IP to that user. It will move to the internet. The second comes to the internet router will assign the second IP to that user, and that the process goes on. At the 255, the last user, because we have 255 public IPs there, it comes to the router will assign the last public IP to that user, and it will move to the internet. It can access the internet. But what happens if the next user comes here for the internet access? For example, 256 user, the next user comes to the router, then there is no public IP available to assign to this host. So if there is no public IP available, it cannot assign the public IP to this user, and that user cannot access the internet unless any other user break its session or like stop accessing internet. Once any public IP again available on the router side, any user shut down his PC or stop the internet access, then the public IP is available, then single public IP is available, and router will assign that public IP to that user, and after that the user can access the internet. That is called dynamic net. In dynamic net, you have a pool of public IP. You assign that public IP pool to all the users, and it works on the first come first serve basis. The user comes to the router will assign that public IP, and user can access the internet, and that process goes on until the last public IP available on the router side. Now come to the pad. What pad does here? You are having a single public IP available, 200.0.0.1 slash, for example, 30. Single IP available here for the internet access. In the pad port address translation, all the users will access the internet using this public IP only, but with the port number, with the adjacent port number. Like the user one comes to the router, it will give you the port number as 1, 2, 3. IP will be same, the port will be changed for all the users, and that can range from 0 to 65,535. Okay, up to this much users can access the internet using a single public IP by configuring the pad. Okay, let's move further. So we have configured what is firewall and types of firewall, why to choose Palo Alto firewall, initial configuration, basic net, and security profile. Let's jump to the lab with for site-to-site Ipsec Vpn. Let's log out this. So here is the setup for site-to-site IPsec VPN. Okay. Have you heard about Ipsec VPN or VPN? So VPN, basically a VPN connection is that which allows you to connect to different local area networks over the internet. It's called site-to-site IPsec VPN, site-to-site VPNs basically. And the IP security, IPsec, that concept is IPsec, right? VPN allows you to connect to different local area network over the internet. We are assuming this is our internet, okay? And the reachability between this router and the Palo Alto firewall happens on the public internet. Both are reachable, okay? So what VPN does here, it connects to different local area networks over the public network. And what is IPsec? IP security. Basically, the IPsec or IP security is a set of protocols is used to set up a secure tunnel for the VPN traffic. Is called the site-to-site IPsec VPN. It just creates a secure tunnel to connect to different local area networks over the public internet to protect your network from the outside threat vectors, because the threat vectors are sitting on the internet. They're just trying to get your information, the data you are transferring from one location to another location. For example, if you are having two different banking sectors, two different sectors of banking, two different buildings are there. Hackers are sitting on the public internet. Okay, they're just trying to get your information, what data you are transferring from one site to another site, maybe some information of the users, username and password, the profile password of the users to hack their accounts. So what IPsec does here, IPsec put that data in a tunnel from one location to another location, and that data which is passing through this tunnel is encrypted, so that the hacker cannot access these information, these data, this traffic, cannot access these. Okay. For IPsec on Palo Alto firewall, we require to configure phase 1 and phase 2 parameters. Let's start all the nodes here. Here on this side, the LAN network is 192.168.50.0. The LAN network of this second side is 192.168.60.0. In between of Palo Alto firewall and the router, we are using network as 10.1.12.0. This is the physical connection. And for the tunnel, for IPsec tunnel, we are using these IPs 10, 20, 22, 22. And to access the Palo Alto firewall, again, we are using the default IP from this management PC. Okay. Topology is very simple. The lab topology is very simple, but it is similar to the actual network where you are configuring the IPsec. Like it's your site 1, it's your site 2, and both the sites are connected over the public network, right? So we have to configure, we have to create a IPsec tunnel in between to secure our network, to access both the local area networks directly over the public network. Let's check the IP address here. Yeah, 192.168.1.100 IP is correct. Let's try to take the access of the Palo Alto firewall. Again, HTTPS default IP 192.168.1.1. For IPsec configuration, IP security VPN. What we have to do is we have to create phase 1, phase 2. So what does phase 1 and phase 2 have like perform here? The main purpose of phase 1 and phase 2. The main purpose of phase 1 is to set up a secure encrypted channel through which the two peers can negotiate. If you are having two different routers, they are connected directly. Okay. So it creates a secure channel. Okay. It creates a secure encrypted channel through which two peers can negotiate. The purpose of phase 2, what is the function of phase 2? To negotiate. The purpose of the phase 2 negotiation is for two peers to agree on a set of parameters. Again, in phase 2, it's used for negotiation for the two peers to agree on a set of parameters that defines what traffic can go through the VPN, like any policy if you configured, anything which you have configured. Here we can assign the parameters that defines what traffic can go through the VPN and how to encrypt and authenticate the traffic. Okay, we'll do all the configuration. Yeah, Palo Alto is live now. Again, the username password admin default. Here in this topology, the router is already configured with the basic parameters. We will configure the Palo Alto firewall. Okay, I'll show you the parameters which is required here for the IPsec formation. Here you can see on the network tab, the IP is already assigned, which we have done in the last topology. It's similar to that, but the IP address is changed. Only the IP address is changed. Okay, same, the management profile is there, and the zone is there, LAN and WAN zone, and the management profile. Nothing more than that. So for IPsec, we'll do the configuration. Okay. So what we have to do is, let's take the access of router as well. Here you can see, this is the phase 1 configuration, the phase 2 configuration. Okay. Phase 1 configuration and the phase 2 configuration. The tunnel configuration, because we have to create the tunnel in between two different devices for the IPsec formation, and the route, default route and the static route. This configuration is done already on the router side, but Apart from that, on the Palo Alto side, we have to configure all the things. Only the interface is already configured. Now we have to configure the IPsec. I told you we have to configure the phase 1 and phase 2, right? So click on the network tab, scroll down this, IKE crypto. Click on that. Before that, we have to create that tunnel. Just click on the interface. Here, our Ethernet 1 and 1/1 and 1/2 is there. On the last tab, tunnel interface, we have to create a tunnel interface. Click on the add button. It will pop up to configure some parameters. So here we have to assign that tunnel interface number. Okay, we are taking we can take anything. Like if you click on this, we can take 1 trip 9,999. We can take anything, any number here from this. We are taking only as of one interface tunnel 1. Now the virtual router. We are taking this as a VIR. Security zone. Again, click on the zones. In our early lab, we took zone as the inside and the outside. But here on the IPsec configuration, that this tunnel interface will have its own zone. Okay, its own separate zone. We are just assigning it as a VPN. Okay, VPN 1 and with there. Now we have to assign the IP address. So this is the physical IP, IP address of the physical interface 10.1.12.0, and the tunnel IP is this. Okay, 10.22.22.1. Click on the add button. Assign the IP address which is there 1/24. Click on the advanced tab again. Create a management profile. Again, enable the services as per your requirement, like ping, SSH, HTTPS, whatever the service you want to allow here on that interface. Ping, SSH, and HTTPS. We are allowing these 3 services only. Okay, click on the OK button. So we have configured the tunnel. Now we have to configure the phase 1 information. Click on the IKE crypto. Scroll down this on the network tab. This page. Click, scroll down. There is the IKE crypto, right? So we have to configure the phase 1 configuration here. IKE crypto is the phase 1. Just assign the name it as a phase 1. Now it is asking for the DH group. Like multiple groups are there. 1, 2, 5, 4, 14, 19, 20. We are taking group 2. Now for authentication, if you click on this, there are multiple authentication mediums: MD5, SHA-1, SHA-256, SHA-384. We are using SHA-1 for authentication and encryption. We are using AES-128, but here you can see DES, 3DES, AES-128. All these are different parameters for encryption. Okay. SHA-1 is for authentication. AES-128 is for encryption. We are using this. DH group is 2 by default. We are using. Okay. And the timers, key lifetime timers is in hours, 8 hours by default. We are taking this timer as it is. We are not changing the timer. But apart from this, DH group, authentication, encryption, we have configured. And make sure at both the ends, this configuration will be similar. Otherwise, the IPsec will not form. Okay. Click on this IPsec crypto. This is phase 2 configuration. Like I told you, the phase 1 is used to secure encrypted channel through which the two peers can negotiate, right? And in phase 2, negotiation is for two peers to agree on a set of parameters. What traffic can go through the VPN, right? So it is phase 2. Phase 2, we are assigning the same name. Here on the IPsec protocol, you can see on the IPsec protocol, we are using ESP. If you scroll down this, if you click on the AH, then we can assign the authentication parameter only. But once we click on the ESP, we can also assign the encryption parameter as well. So we use ESP always. Again, we are using encryption as AES 128, authentication as SHA-1, DH group 2, and this information is default. So we are using the same information here. We use the group DH group 2, and for phase 2, ours lifetime is 1. Click on the OK button. Now IKE gateways. Okay. All the things, the phase 1 and phase 2 configuration, we have to map here. Like interface, we have to select the WAN interface here. Once you click on the WAN interface, it will show you the IP address. Click on the local IP address, scroll down this, it will show you the IP address of that WAN interface. Now it is asking for the peer IP address. So what is the peer IP address? It's 10.1.12.0. 10.1.12.2 is our peer IP address. Okay. So pre-shared key, we are using CCIE in a small CCIE. Advanced tab, click on the net. We have to call that phase 1 configuration here. Click on the OK button. Till this point, we have configured the phase 1, phase 2, and gateways. The last thing, we have to configure the IPsec tunnel. Here on the same page, on the network page, there is the IPsec tunnel. Click on this, click on the add button. All the configuration you have done here, just need to assign that configuration here in this IPsec. Okay. Just put it as IPsec tunnel. Tunnel interface will be tunnel which we have configured tunnel.1, right? IK gateways, which we have configured, and the IPsec crypto profile, that phase 2. Click on the OK button. Once you click on the save button, that configuration is committing. So before that, we have to give the static routes. We have configured the default route from this destination to that destination, right? From this source to destination. Now what we have to do is we have to assign the static routing, right, to access the vice versa traffic over this tunnel. So for that, what we have to do, click on the virtual router, the VIR virtual router which we have configured. We have assigned all the interfaces to that VR. Click on the static route. Assign that static RTR. The destination. What will be the destination? 192.168.60.0/24. We are here on this side, so we have to access this 60.0 network. So we are assigning the static route from this source to this destination. 60.0. Once you click on the interface, we are having different interface, so we have to use the tunnel interface here. Next hop IP address, the tunnel IP address. You can see here the tunnel IP address of the router. Click on the OK button and put this commit. Okay. Configuration is very simple. It may be like a little complex for you, but if you perform this lab in your home, then it is very simple for you. Okay, now configuration is saved. Now we can check whether this tunnel is up and now. Yeah, IPsec tunnel is formed, but you can see the status is showing down. The status of phase 1, the status of phase 2 is showing down, right? To check this, what we can do, take this, the console access of the Palo Alto firewall. The username and password is same for both, for CLI and GUI, admin. Show interface all to check the interface configuration. Let's try to ping the router from the interfaces. Ping 10.1.12.1 host 10.1.12.2. The physical connection is there. Up, we can ping from this interface 1/2 to the router's interface. Let's try to ping from the terminal interface 10.22.22.1 to host 10.22.22.2. It's pinging. The terminal interface is also pinging. Let's check. Still, it's showing down. Yeah, it came up. You can see here, it came up, right? It means our IPsec configuration is working. We have formed the IPsec tunnel in between the Palo Alto firewall and the router, and that tunnel is working fine. Okay. Let me know if you have any doubt till this point. Is it mandatory to give next scope for channel destination? Yeah, it's mandatory, because if you are not assigned the next hop information, then your traffic will be black hole. Where the traffic will move, I'll tell you. Here in our topology, we are doing all this configuration in the live environment, right? So these interfaces are directly connected. But in real-time scenario, if you are talking about the real scenario, this is not the directly connected network. There is the internet, the public cloud network, or the MPLS, whatever the medium it is, the internet. Okay. So from this point, on the Palo Alto firewall's WAN interface, we have to assign the gateway, the IP address, right? Next hop information for the default route, and again the next hop information for that tunnel to access the internet and to access to different local area network of the public network using Ipsec VPN, right? So at both the sides, we have to assign the gateway, next hop information. Okay. Or else your traffic will not move from this location to another location. It will be black hole. Let's check checking this IPsec formation, IPsec tunnel formation on the CLI side. What we can do, show VPN IKE SA. IKE SA is for the phase 1 configuration. Okay. Actually, it's a simulator, so it's showing in the mesh. Okay. Otherwise, you can see phase 1 SA is there. Phase 1 SA, phase 2 SA, IKE gateway, the tunnel address, the physical address of, yes. It is showing IKE SA total 1 gateway found, 1 IKE is found, right? If that tunnel, like, is there any like mismatch of the configuration, then it will not found the SA parameters, and that tunnel will not form. Okay. This command is to check the phase 1 configuration, IKE SA. If you perform the Ipsec SA, that is for the phase 2 information. Ipsec SA, you can see these details here. Total 1 tunnel found, 1 Ipsec SA found. Okay. And if you are talking about the router side, we'll check this as well. So crypto, Isaac MP SA for phase 1. Destination, source, state, connection ID, and state. Yes. And for phase 2, that is called Ipsec SA. So these details you can like verify. If you want to go deep dive in this, you can issue that command and check all the parameters here, like current peer, right? Inbound ESP SAS, the phase 2 configuration, the flow, the connection ID, all the things are there. Okay. So this network is able to reach to other sites over the IPsec, which we have formed in between the Palo Alto firewall and the router. Okay. Let's close all these nodes. So these topics already covered. Now the HA basic setup. We'll perform the HA configuration high availability between 2 different firewalls and check whether this HA is working or not, and what parameters are required to configure the HA. Okay. Let's take the last lab here. Open this. Have you configured HA like on the router side, where we are using like VRRP, HSRP, and GLBP? It might actually, the configuration of the IPsec might be a little complex for you, but it is as it is. Okay. So the topic is high availability here. The term high availability refers to a network or a system that is designed to avoid loss of services by reducing the number of network failures. For example, if we assume that this part is not there, your LAN network is there, one single firewall, and the single firewall, and the internet is there. You are relied on this Palo Alto firewall or this router. For example, if this Palo Alto firewall fails, what happens? This is your single point of failure. This firewall fails, it means your complete network is down. You cannot access the internet at that time because your complete setup is down. This primary gateway for your LAN network is down. Same for this router. If here you are using a single router and that router fails for any reason, any physical damage, any power cut, any iOS corruption is there, it means that router fails and you don't have any medium to connect the internet at that time. So for that, at that time, what you can do is you can replace that hardware with another router if you are having, and most probably it will not be there, and or you have to wait till the time the RMA router or RMA firewall comes to your location. You configure that hardware and place it to back in the rack, right? To avoid these kind of scenarios, we use the high availability HA basically. So in HA, what we have to do, we have two different firewalls, right? We are using two different firewalls as active. The one is active, the other one is as the passive. Passive firewall will remain up and running in real-time sync with the active firewall, but all the configuration related, or table related, all the packet forwarding related things happens on the active firewall side only. Passive firewall is there in the complete sync with the active firewall, but it doesn't participate in any kind of packet forwarding, any kind of traffic forwarding, any kind of ARP learning. It just plays in the backup. Once the active firewall fails, for example, this active Palo Alto firewall fails, at that time, backup firewall comes into the picture. Then it takes the authority from the active firewalls to perform all the things, all the traffic forwarding, all the ARP learning, all the internet access, all the session creation. Okay, at that time when the primary or active firewall fails. So high availability is mostly you can see in mostly all of the organizations as of now, because companies rely on the data. They don't want to disturb their network for a single hardware box. If that box fails, then their complete setup fails. So they cannot rely on a single hardware, single router, or single firewall. They put two different routers, two routers, two firewalls for redundancy. Okay. Here in our scenario, we are going to cover active passive scenario. Okay, active passive scenario. Active scenario is also there, but we are going to cover active passive scenario where the first firewall will work as the active and perform all the traffic forwarding, all the session creation, all the ARP learning, and the second firewall will be backup of that firewall. Okay. The Cisco SA basically that HA, that high availability, is known as the failover, but in Palo Alto it is called as the HA. Okay. So here in the Palo Alto, we have to configure two different interfaces. We have to connect to two interfaces, and we have to configure both the interfaces. The first one is the HA1, the second one is the HA2. HA1 is known as the control link. The HA2 is known as the data link. Okay. The difference between the control link and the data link is the HA1 link is used to exchange hellos. All the hello packets are sent over this link, HA1. Okay. Heartbeats and HA state formation information, all the information which we configured for HA, that state information will be passed through on this interface, and management plane synchronization for routing and user ID information. Just a second. HA1 link. So what information move on this link? Hellos, heartbeat, and HA state information, management plane synchronization for routing. Okay, all this information is passing through on this link HA1. Now come to the HA2. What information is there on this link? HA2 link is used to synchronize sessions. All the session synchronization happens on HA2 link. Forwarding table, all the internet access information like RIB and FIB is there. IPsec security, and ARP learning, ARP table basically is there. It passed through on HA2 link. Okay, all this information is passing through HA2 link. Let's jump to the lab again. Let's start all the not all the nodes. We just need to start this Palo Alto, and both the management PC. Like similar to Cisco environment, if you are configuring two different routers in HA using VRRP or HSRP, whatever the protocol you are using, so you assign some priority, right? For HSRP and VRRP, you assign some priority for a router to perform the task as active, right? Same here in the Palo Alto, we have to assign the priority. Based on the priority, our Palo Alto firewall performs the functions as the primary or the backup. By default, the priority is 100. Like lower the value, higher the priority. By default, it's 100. If we assign the priority level as 90 to this firewall, and for example 110 to this firewall, it means this Palo Alto firewall will work as the active firewall, as the primary firewall, and the other one will work as the backup. Okay, let's check that. Let's confirm the IP address first, whether it is in the same subnet. Yeah. Let's try to access the Palo Alto firewall with the same default IP address, 192.168.1.1. I'll tell you here in this topology, we are not configuring the LAN interface, the WAN interface. We are just configuring the HA. Okay. We'll test the HA. We are configuring the HA here. I think services are not running. On 192.168.1.1. Let's try to ping this. Ping 192, I think, yeah. Actually, it took around 5 to 10 minutes to start all the services. Once all the services are like completely up and running, then after you can take the access. Okay. So configure both the firewalls simultaneously. CPS 192.168.1.1. It's PC1 and the firewall 1. Okay. Like we are taking the example for the single link for HA1, the single link for HA2, but Palo Alto provides us some advantages. Okay, so for according to that, what we can do, we can use a backup HA link HA1 and backup HA2 link as well. Here, if you are having the ports available on the Palo Alto firewall, you can configure the backup links for HA1 and HA2 as well. Like if you are having the high-end firewalls and you are having like multiple ports available on your Palo Alto firewall, then you can connect the backup link for HA1 and HA2 that provides the interface level redundancy. For example, if your interface fails, both the interfaces HA1, HA2 fails, then these backup HA1, HA2 comes to the picture, and your session or all the like HA configuration will be synced, and there is no like any kind of disturbance happens to your network at that time. But in our topology, we are using the single link for HA1 and single link for HA2. Okay. So for HA configuration is very simple. Let's jump to the lab first. One more thing, actually, I want to tell you. For HA configuration, like both the boxes, both the hardwares should be with the same model, with the same license set available on that box, and even though the interfaces should be same. Okay. All right. Like all these information should be identical. Then after you can create that chain between two different firewalls or two Palo Alto firewalls. Like the hardware model, the licenses should be same, and even though interfaces should be same. By default, preemption is not enabled on the Palo Alto firewall. Like in routers, for example, Cisco routers, if you are configuring the VRRP. So preemption. So what is preemption? When a primary firewall fails, for example, this firewall is working as the primary and this is working as the active, so backup firewall. If that primary firewall fails, then the secondary became the active firewall. And once that primary firewall comes back and like boots up again, or maybe any reboot is there, any unwanted uncertain reboot is there on the Palo Alto primary firewall, at that time backup firewall will act as the primary, because this primary firewalls are not available at that time. But what happened if the primary firewalls came back again? So at that time, preemptions comes to the picture, and once primary firewall comes up at that time to take the responsibility back, preemption is required. Otherwise, secondary firewalls will be active unless it fails. Clear? If that primary firewall fails, the backup firewall will become active. It will start like all the processing, all the session and app table learning, all the forwarding, all the things will start from this firewall. But when the primary came back after some time, after 5-10 minutes to 20 minutes, 30 minutes, after, for example, 1 hour, if that primary firewall came back, at that time preemption should be there so that it can take the responsibility back from the secondary firewall. But by default, preemption is not enabled on the Palo Alto firewall. We have to enable that preemption. Okay. Let's start the configuration. It's already there. what you have to do is, for example, if that interface will be the part of tap mode, you just need to assign those interfaces to HA only. You click on the drop down button on interface type, click on the HA, that's it. Here are some different configuration if you want to assign the link speed, link duplex, or link state. We are not manipulating these. We are using the default configuration. Just if you want to assign the link state up and down, so we are using the auto. If you are having like different configuration for link speed, like Ethernet, fast Ethernet, or gigabit Ethernet, if you want to assign the duplex, like half duplex, full duplex, as per your requirement, you can configure that, but we are using the default. We are just assigning that interface to the HA, right? Same for this interface, only assign the interface to HA. We are using it in Ethernet 1/2 and 1/3. Both the interfaces are assigned to HA. Let's check on another, the second firewall. Again, the username and password admin default. Click on the network tab. Here it is already assigned in the HA. Okay. Click on the device tab. Just wait, I'll put it side by side. PC1 is connected with the firewall 1, PC2 is connected with the firewall 2. Firstly, we'll configure the PC1 firewall 1. The configuration is very simple for the high availability. On the device tab, the second option is high availability. Click on this. On the general tab, you can see multiple configurations like setup, control link HA1, data link HA2. You can see here the control link HA1 backup. I told you we can use the backup link as well for redundancy of the interface. But here in our topology, we are not configuring this backup link. Let's try to configure this. Click on the setup. Firstly, you need to enable the HA. Now, you need to assign the group ID. Once you click on this, here you can see it is having the number from 1 to 63. The range is 1 to 63. The group ID number can be between the range of 1 to 63. So we are taking it as 10. That group ID should be same, identical on both the firewalls. If you want to assign the description, HA firewall, we can do that. Now it is asking for the peer HA1 IP address. Just close this. Now this peer HA1 IP address. So the IP address for the peer HA1 is 10.22.22.2. Okay. Peer means the adjacent router, not the local router. Okay. The adjacent router's IP address is 10.2022.22.2. Click on the OK button. Scroll down this. It is asking active passive setting. Click on this. Now it is asking for the passive link state. We put this as auto. We are not putting it as a shutdown. We are putting it this auto. Scroll down. Now it is asking for the election setting configuration. Let's check this. By it is having the device priority 90, we are putting because this firewall will work as the primary firewall. So 90 is okay, but let's change this to 50. Here you can see the preemption, the heartbeat backup. So preemption should be enabled. Otherwise, your backup firewall will not release the active state once your primary firewall fails. Click on this. Click on OK. Now configure the HA1 link information. Click on this. Here you can see by default it is on the management interface. Palo Alto basically recommends to connect your HA1 link through management interface to save your interfaces for other network connections. But if you are having like multiple ports available, then don't use this management interface. You can use other interfaces. For HA1, we are using the interface Ethernet 1/3. The IP address is 10.22.22.1, net mask 255.255.255.0. Click on OK. We are not using the HA backup link. Now come to the data link. Here is a small icon. Once you click on this, it will open the configuration part. Okay. Now it is asking for the IP address. What is the IP address for data link? We are using 10.23.23.1. 10.23.23.1. Net mask again 255.255.255.0. Click on the OK button. All right. That is all the configuration is done for the HA on the primary firewall. Click on the dashboard. Here I told you like how to enable the widgets. Here you cannot, you can see there is no HA tab available. So click on this widget on the system. Here you can see high availability. Click on this. It will show you the tab for high availability. As of now, HA is not configured because that configuration is yet not saved. Click on the commit button. Meanwhile, we'll configure the second Palo Alto firewall. Again here on the HA side, enable HA, group ID is 10, description, HA firewall, the IP address of peer 10.22.22.1. Here on the mode side, you can see we are using active passive, but active is also there. But as of now, we are using active passive only. Click on the active setting. Again, the passive link state should be auto. Okay. Again, scroll down. Now it is asking for the election setting. Click on the configuration part, preemption, heartbeat, device priority is default 100. We are changing it to win 150. Click on OK button. Now we'll configure the HA1 link. It is again on the management interface. Scroll down this. So HA1 link is Ethernet 1/3. Click on this 1/3. The IP address is 10.22.22.2. That mask is 255.255.255.0. Okay. Now we'll configure the data link HA2. Click on the configure tab. It is asking for the IP address 10.23.23.2. Let me confirm this. 10.23.23.2 here. The net mask again /24 255.255.255.0. That's it. Click OK. Again, come to the dashboard. on the widgets, system, and then high availability. Once you click on this, it will show you the high availability tab again here. It is added to your dashboard. Here is added to your dashboard, but still it's showing HA not enabled because we have configured that thing, but still that configuration is yet not saved. Click on the commit button. That's back to the firewall 1. Configuration is saved. Just a second. It is giving some error. It is saying that HA2 port is not configured. Let's see. Yeah, port is not selected. My mistake. HA2 is for Ethernet 1/2. Yeah. Now it will save the configuration. Same again on this firewall 1. Go to the device tab, high availability, scroll down this. Yeah, data link, HA2. Here, this port is set to the none. We have to select the HA2 interface, Ethernet 1/2. Click on this, OK, and commit. Configuration is saved on the secondary firewall and in the process on the primary firewall. It's almost done. Configuration committed successfully. It's showing 99%. Close this. On the dashboard tab, you can see now all the HA configuration is showing, like the mode is active passive, the local is passive. It should be active, but as of now it is showing passive. No, okay, local is passive. It's PC1. Yeah, it should be active, and it is showing the peer is active because at that time that because we saved the configuration on the firewall 2 first and secondary on the firewall 1. Once I refresh this, it will change the role. Apart from this, it is showing the app version match, threat version match, antivirus version match, PAN-OS version match, global protect version match. If any of these information mismatch, it will not form the like HA, right? Now HA1 is up, HA2 is up, heartbeat backup is up. Okay. Let's try to sync this, refresh this. Now it is showing the local as active, right? It changed the role. Now it is active. The secondary PC2 is passive. Apart from this, all the information is there. All the configuration is synced. Let's try to check the like HA is working or not. Let's try to configure one of the interface here. It is tap mode, and on the firewall 2, let's check this. It is in the tap mode. Okay. Try to change the role to layer 3 interface and virtual router as default, security zone as LAN, and the IP address. try to assign a dummy IP address 1.1.1.1/24. Click on the OK button. Then commit the configuration. That configuration should be synced with the backup firewall. It will take some time because it's the virtual environment, but in the real-time scenario, it will be in the real-time sync. Once you click on the commit, that commit performs. Once the commit happens, it will directly sync the information with the backup firewall. Commit happens. Okay, successful. Now click on the dashboard. Let's try to check. Yeah, refresh this page. It's still in the tab mode. Okay, so what we can do here on the running configuration, you can see sync to peer is there. Okay, just click on this sync to peer, forcefully syncing from the primary firewall with the backup firewall. Let's check this if that happens or not. It will take some time. Yeah, that configuration is reflected here. The IP address, the interface type of the interface 1/1. Network. It is showing the link of 1/1 as up because something is connected here on this interface, but on the secondary firewall, nothing is connected. That's why it is showing in red. But the configuration sync is done. We configured the IP address and the interface type on the primary firewall. It is synced with the backup firewall, right? Let's try to check with it is the backup firewall is in passive, right? Just a second. The backup firewall is in, the local firewall is passive. What we can do, we can shut down the primary firewall and check whether it is taking the role or not. Then we'll start the primary firewall to check the preemption is enabled or not. What we can do, stop the primary firewall. Let's check on the secondary, refresh this. Still it's showing in the passive. Local firewall is passive. Alto firewall PC1 is followed to firewall 2 should be there. Yeah. Min admin, username password admin by default. It is showing some errors, maybe due to this virtual box, like suspend internal HA error, please call to support. But normally it will be like move its state from passive to active. But here it is showing some errors. Let's try to reboot this firewall as well. I restarted the firewall. Let's check the state again. PC2. HTTPS limited 168.1.1. Try to ping the Palo firewall on Twitter. It's pinging. Let's wait for another 1 minute. Services are still running. That's why it is not giving the access. Still, our primary firewall is down. We are accessing the secondary firewall and checking the state of the secondary firewall. We rebooted the firewall because it's showing some error. It's in the initializing state of our HA. Let's wait. Yeah, here you can see now the local firewall is active, which is running as the passive earlier. Once we once we shut down the primary firewall, the firewall 1, the backup firewall took the responsibility as the primary firewall. Okay, it is showing all the things it's showing, but apart from this, only HA2 is live and the local firewall is running as the active. Remaining things in the sync mode because it is trying to check the peer is live or not. Still, they are polling with the primary firewall, but as that firewall is down, so these ports, this configuration is showing as the sync in the yellow color, and HA1 and the heartbeat is in red because it is polling. It is trying to poke the adjacent firewall, the primary firewall, and but not able to reach that firewall. That's why it is showing in the red color. Let's try to power on the primary firewall again. Then after we'll check whether this primary firewall will take the responsibility back from that firewall 2 to firewall 1. Still in the voting phase. It's taking time to start all the services. Thing is working. Why is not running? Yep, now it's gained access. Admin. Alto Firewall 2 is running as the active firewall as of now. Need to check whether this primary firewall will take the responsibilities back. It boots up with the passive mode, local as passive. Try to refresh this. It's still in the passive mode. They are trying to elect the passive and the primary firewall. Yeah, it came back to as active firewall. On the PC1, it is connected with the firewall 1, right? Now it came back with the active. It means preemption is also enabled. Preemption is working. The real-time sync is also working. Apart from that, all the things are matched again. So these, it's showing in the right green color. It means all the things have been matched again. And the peer is working as the passive. So it means HA is working perfectly fine. The picture will be more clear once you perform the lab by yourself. This is showing active. Once you refresh this, it will change the role like passive. Okay. Just give me a moment. So as of now, we have covered all the topics for today. I hope today's concept is clear now to all of you.